Okay, in this calculus question it says given f of x equals the square root of x minus 2, find f prime of x from first principles. This is an absolutely key phrase, from first principles. They could also say using the definition. It's the same thing, using the definition of the derivative. So this is one formula we're definitely going to want to memorize, and we want to see how it works. So once we get through derivatives a little further in our calculus life, we know how to find the derivative of square root of x minus 2 really quickly because we develop shortcuts. But we do want to see where that actually comes from, and that starts at the definition of the derivative. So let's fully write it out, try and get all of our tidy communication marks here, and make sure we get this right. So the derivative, or f prime of x, of a certain function is a limit, as h goes to 0, of f of x plus h minus f of x all over h. If you don't understand this, it doesn't usually matter. You do need to memorize it, though. What it is it's just the slope formula where we're taking the distance between the 2 points, or the run, the horizontal distance, down to 0. We're trying to make that absolutely tiny, so it's like you're barely moving off the point, and that'll give us the instantaneous rate of change, which we call the derivative. Okay, so now, knowing that, let's keep writing limit. Make sure you write limit every time until we actually sub in 0 for h. The reason we have to keep going here is because there's an h on the bottom, so you can't just sub in 0, otherwise the bottom would go to 0. F of x plus h. Well, if f of x is the square root of x minus 2, f of x plus h, we're just going to sub x plus h in for every x. So instead of x minus 2, it'll be x plus h minus 2 under the square root. Again, all we're doing, you can think of x plus h here as sort of a sticker, and we're just covering up the x with an x plus h sticker. Minus f of x, so that's literally just a straight copy. F of x is square root of x minus 2 all over h. Every step of the way we're going to be saying, is there a problem? In other words, if you sub in 0 for h right now, does the bottom go to 0? Yes, it still does, so we have to keep going and do something else. Can't do much to the bottom right now, so let's look at the top. And our x's are trapped under square roots. That should be a good clue, as we've gotten really good at limits, to use the conjugate. The conjugate just means we multiply top and bottom by the exact same thing that's on the top, where the x's are trapped, just change the sign in the middle. So let's take a look at how that will work. Even if we don't know that that's the right play, there's really no other way of saving these x's under the square root. So minus the square root of x minus 2, so I'm rewriting what we have first, and then I'm going to say I'm going to multiply top and bottom by the exact same thing on the top, so x plus h minus 2, except for the minus between here, I'm going to change that to a plus. And the reason for that is that the square root should go away if we've done everything right. You can't just multiply it to the top, you have to do the same to the bottom. X plus h minus 2 plus the square root of x minus 2. Okay, so let's see how that works. I'm not going to multiply the bottom out because I know that this h here, that's my issue, right? It's not the h anywhere else, it's right there. So let's see what happens. We get the limit as h goes to 0. The bottom remains the same, so I have h into this bracket. I'm not going to multiply it out. X plus h minus 2 plus the square root of x minus 2. On top, let's look at what I'm going to put a bracket around this guy just to show how it works. So this is actually going to be FOIL, but because the signs are different, the middle term is going to cancel. So all that happens is when we multiply the first term by the first term, the square roots go, and we're just left with x plus h minus 2. And the last term times the last term is minus, again the square roots go, it's just x minus 2. The terms inside will cancel, right? We would get negative square root of x minus 2 times square root of x plus h minus 2 when we multiply these guys, and we'd get the same thing positive when we multiply these guys. Same thing positive, same thing negative, they'll cancel and they'll be gone. So now it looks like we might be in better shape. If all goes to plan, we should be able to simplify the top, and we get x minus x, so this is gone with this. Negative 2 plus 2, so this is gone with this. Make sure you multiply that negative in, so that's why it cancels. So we're just left with h on top. On the bottom we still have h into square root of x plus h minus 2 plus the square root of x minus 2. And again, if all goes to plan, this should work out really nicely, which it does. We know that h on the bottom is our problem. We can now cancel that with the h on top. Make sure you put a 1 there. Now you say, is there a problem? In other words, can I sub that 0 in for h? Yes, you can. So we don't write limit anymore. This is just 1 over the square root of x plus 0 minus 2, because I've subbed in 0 for h, plus the square root of x minus 2, which is just 1 over 2 square root of x minus 2, because there's 2 of them here, 1 and 2. 0 minus 2 is just minus 2. And this is our derivative, and you should be able to do that, like I said, through shortcuts as well, but they could easily ask you from first principles or using the definition of the derivative, and we have to follow these steps. Just keep in mind that the derivative is still a limit. We've gotten really good at limits, so we should be able to handle these. You can always send us more questions, info@arnoldtutoring.com. Thanks.